Hello and welcome to part 4 of the Introduction to Scratch and Block Coding tutorial series. In this tutorial we will be looking at adding in a basic level design with walls and getting our sprite to sense whether it's touching the walls and avoid moving through them. We're going to start with a really basic sort of level layout. It'll be literally a box, but part of the testing into making sure your boundary sensing works properly is basically, can the cat get out of the box in each direction. So let's get started. Moving over to our Scratch or our Sprite palette here in Scratch, you can see we have currently our little Scratch sprite, and we're going to create a new sprite. So this is a really great way to do level design. It's probably the cleanest code-wise that I've been able to find so far, and it's what I use as kind of the standard for my games at the moment. So I'm going to mouse over my Choose a Sprite, and instead of clicking here on Choose a Sprite, what I am going to do is I'm going to click the little paintbrush tool, and that means I'm going to design my own sprite. I'm going to click once, and you'll see that I create a new sprite. It's called Sprite 1, and it automatically goes into the Costumes tab because you need to create the sprite in order for it to be a visible object in your game. So this is the basic sprite design layout here. I do want to just quickly draw your attention to this little blue button here at the bottom, Convert to Bitmap. You want to make sure it says Convert to Bitmap right here because it means that you are currently in the vector-based drawing format. So if you click on that little icon right there, click on it, it says Convert to Vector. You notice the sprites or the little icons here change. They're kind of like pixel art based. That kind of gives you the clue that this is a pixel-based drawing setup. So you want to make sure that you hit Convert to Vector so that it says Convert to Bitmap there, and you get these nice clean-looking tools on the side. If the tools on the side look clean and not pixelated, you are in the right setup. So what you want to do is we're going to change our fill. We're going to go down here to the bottom left-hand corner of this drop-down menu and just click this little red line through a white square, which means empty. Outline is black, that's fine. I'm going to change the outline to 10, and I'm going to make a couple of important distinctions right now, or changes to what's going on. So I move over here to my sprite sheet. You'll notice this is called Sprite 1. It'll basically go Sprite 1, Sprite 2, Sprite 3 as you create these. I'm going to change the name of the sprite. This sprite is going to be called Level Design. So actually we're going to call it just levels, or level. Yeah, we're going to call it level. So level is basically, it's going to be the parent sprite for a whole series of different costumes, which will be the various level designs for each of the levels in the game. Then I'm going to go over here to my costume design. I'm going to change the costume name up here in the top left-hand corner to Level 1. So this is a really great way of creating your level designs, because when you're doing essentially a sensing code to tell you whether you're touching the level, it doesn't matter which costume it currently is in, it will always sense if it's touching the sort of the parent level sprite, as opposed to having to program in a little bit more complex stuff for each level. It makes things a little bit easier. So let's create a very, very basic level design, and we'll add to it as we kind of do a little bit more coding. So I'm going to go down right here to the bottom, look at the little square sprite here, rectangle. Fill is once again empty, outline is black with a line weight of 10. I'm just going to click and drag, create a little rectangle, then use my direct selection tool to click on it, move it, and it should click right in here. Now, something really important to note, and this annoys me personally about how Scratch's default setup. You'll notice in my preview here, the rectangle appears, but it's kind of off. It's not on center, even though right here it's on center. This canvas right here is actually the exact same dimensions as your game screen. So it's annoying when you're creating a sprite to not have it sort of automatically be centered within the game screen. It kind of like creates almost a random drop. On here, I'm not sure why it would do that, but it aggravates me a little bit. But it's not a big deal because we are going to make a couple of changes to the code for our level. just to make sure it always kind of sits where it's supposed to sit. So this is it for our level design at the moment. I'm going to go through making more changes later, but you're going to create a basic little rectangle, make sure it's centered. Now let's go to our code, and we're going to add just a tiny bit of code to this. Making sure the stop button has been hit. This is really important with a lot of the code, because if the stop button is hit, it basically allows you, Scratch will auto grab the coordinates of whatever object you're clicking on. So in this case, my level design, and it allows you to do a few little things. So let's click on our events. When the game starts, and what we're going to do here is we're just going to make sure our level always starts at the correct size and the correct position. So we're going to go to when the game starts or the go flag's clicked. We don't need to have a forever block or anything, because this only has to happen once when the game starts. All we need to do is we're going to do a go to XY coordinate. And grab this and drop this in there. Now you'll remember from the previous video, dead center, using the center point of an object in the screen, is 0, X, 0, Y. If you actually double click on it, it will run the code. So go to X0, Y0, and that moves the level sprite right to the exact center and proper layout for what it should be. Now if you're working on the rest of this, everything that you draw in the costumes will basically fit within this exact layout. Okay, so let's get this cat in the box and make sure he can't escape. Let's click and drag the cat, or Scratch, and let's go to his code. And let's create some code that is going to keep him in this box. Now, boundary sensing is actually directly tied to your movement block of code here. So this is our movement block. This is where all our movement inputs are. And if we're going to do boundary sensing, it's actually tied right into these inputs. Remember, coding is a very, very specific grammar. If you have not coded it, it will not occur. It doesn't make inferences or have intuition about what you might mean having done something else. You must be very, very specific about every possible step. So we're going to create our boundary sensing here, basically if statement by if statement. We're going to add 4 more if statements in here, and we're going to do what's called a nest. So if I go to my control blocks, I'm just going to demonstrate what I mean by that. So if you grab an if-then statement, an if-then statement is basically a gate. We talked about this in the previous video. If the statement is true, then the code inside the if-then statement will be run from top to bottom. If you take another if-then statement and you stick it inside your first if-then statement, you're basically creating a series of gates within gates. So this interior if-then statement can only be run if this exterior if-then statement is already running. It's basically like a series of nested rooms. The only way to get into the rooms that are inside the rooms is to already be in the first room, go into the second room. You could even go even further, and you can like nest down as far as you want if that's something you need for your code. But I'm going to just get rid of these two because we're going to create this if-then statement, and then we're going to drop it in here. Actually, we're going to drop it in, then we're going to start coding it. So, yeah, that's what we'll do. So I'm going to grab this if-then statement, and I'm going to drop it inside my first bit of code here. So right underneath the change x by 10, notice that I'm inside the if right arrow pressed statement. Drop it right there. So the reason we're doing this is we're basically having it so that when we sense the boundary, it only occurs when we're moving. And that keeps us from sort of getting caught in walls and weird things happening. So if-then statement, what we'll do here is we're going to sense if we're touching the level sprite. So basically anything solid in the level sprite. So I'm going to go to sensing, and what I'm going to do is we're going to grab a touching sensing. So touching, notice here if I click on the drop down, edge or level. This will update and expand depending on the number of sprites you have. It'll basically list every sprite here plus the mouse pointer and edge options. So I'm going to click level there, grab it, and drop it in here. So if touching level, we're going to basically make it do something. So as of right now, if I play my game, you'll notice that if I'm touching the level, nothing happens. I can walk right through those walls because we haven't programmed in what happens when we touch the walls. Now, the way boundary sensing works within a virtual environment is a little different than actual physics. So what we are going to do here is I want you to try and understand this concept. If I am pressing the right arrow and I'm changing x by 10, I'm going to be moving 10 units to the left, or sorry, to the right, until I get to this point, and my mouse is still down, and now I'm on, or I'm touching this wall, right? So as soon as the sprite will overlap the wall, this second if-then statement activates because my right arrow is still down. So we want the sprite to stop moving. But we've got to remember, this right arrow was still pressing down, so we're still changing x by 10. So in order to get the sprite to stop moving, despite this code right here still running, is we basically have to cancel this code out. We can't stop this code. We have to cancel it with an equal and opposite code, which is really easy to do. We go to motion, and we grab a change x by block. I'm going to drop this inside here. And so what we're trying to do with each of these if touching level statements is, because this is continuously running while the right arrow is down, or whatever arrow it happens to be, and you're changing your value here by a certain number, this value right here, when you touch the level, in order to create zero movement, must be the exact opposite. So you want to basically set it so that the end product is 0. So positive 10 must be combined with another number to equal 0. So in this case, that would be the exact opposite is negative 10, right? Positive 10 minus 10, or plus negative 10, if you want to use that grammatical sense, equals 0, which means 0 movement. So basically what's going to happen is it's going to go plus 10, plus 10, plus 10, plus 10, touch. Oh, I'm touching, minus 10. Plus 10, minus 10, plus 10, minus 10. It's actually jumping back and forth. It's like in one of those animes where it's like, but actually he's not moving at all. So it will appear to you as if he is stopped. But what's actually happening is it's jumping in and out of the wall so fast you can't even see it. And so it looks like it's not moving at all. Let's give that a little test. So notice, now stops at the wall even though I'm still pressing the arrow. Can go up, can go down, can go left, but can't come through from the right. So only the right block works now. So we're going to continue in the next video getting all the other blocks, or all the other blocks here of movement input the same. So I'm going to stop this video right here, and then the next video we'll continue on and we'll make sure that he cannot get out of this box in any direction.